Today we're going to do a lesson dealing with sets. We already know some sets of numbers, so let's start off by reviewing those. And I'm also going to give you some new symbols for those in case you run across them. We've got number sets. The first one is the natural numbers, and that's the symbol right there. It's an N with two crossing lines. We also call the natural numbers the counting numbers. And hopefully you remember what the natural numbers are. They're 1, 2, 3, 4, 5, and so on. All right, the next set we're going to talk about is the integers. Look at this cool symbol. It's like a Z with two crossing lines there. They're integers, and hopefully you remember what the integers are. They are the natural numbers, 1, 2, 3, 4, 5, 6, 7. Also the opposite of the natural numbers, negative 1, 2, 3, 4, 5, 6, 7. I'm sorry, negative 1, negative 2, negative 3, and they also include 0. So it's really the whole numbers and their opposites. We don't have a cool symbol for the whole numbers. How about this Q with two kind of little extra lines there? Those are called the rational numbers. There's a reason we use a Q. It's because all rational numbers can be written as fractions or quotients. So that's the symbol for rational numbers. And one more. We got this funky looking R here. And that is for the real numbers. Okay, and real numbers are any numbers that you can point to on a number line. Okay, so just thought I'd throw those symbols at you. I also want to throw some set notation symbols at you, and this is going to be the majority of our lesson here today. We've already seen these symbols, and we know that anything in there is the set of. This symbol looks like a kind of a curved E, means is an element of. This same kind of curved or sideways U here means is a subset of. And this kind of upside down U is the intersection of. And one more here. How about, I'm sorry, two more. This U is the union of. And the 0 with a cross through it is called the empty set, and that's when there's nothing in your set. There are no values in the set. So we're going to use a few of these today throughout our examples. I think you're going to be referring back to lesson 90 a lot when you see these symbols, and I would definitely recommend you do that. So write them down right now, and that way if you forget what they are, if you don't use them a lot, you will forget what they are, and they'll just be there in lesson 90 waiting for you. Okay, indicate if the number is an element of the set of integers. So indicate if the number is an element of the integers. So is negative 1 an integer is basically what we're saying. Yes, negative 1 is an integer. So we'll write negative 1 is an element of the integers. I guess I could have used those new fancy symbols I just gave you. I could have used that Z. What about 2? Is 2 an integer? Yes, 2 is an element of the integers. And one more. How about the square root of 3? Is that an integer? It is not. And we can just make a slight adjustment to this symbol for element. It's not going to blow your minds, I don't think, too much. Square root of 3 is not an element of the integers. So we just put a cross through it, and that means not an element of the integers. What about the square root of 4, guys? Do you think the square root of 4 is an element of the integers? You're right. The square root of 4 is an element of the integers because square root of 4 is 2, and 2 is an integer. We just said that up here. So obviously the square root of 4 is an element of the integers too. That was like an episode of Dora the Explorer or something where I wait for you to respond. You know what I'm talking about. All right, use the subset symbol to show the relationship between A and B. Okay, so we're trying to figure out one of these is a subset of the other, and we're going to use the subset symbol to show. Okay, so set A is the set of all triangles, and set B is the set of all polygons. Are all triangles polygons, or are all polygons triangles? Well, all triangles are polygons, so what we say is A is a subset of B. That's it. It looks like ACB, but it's kind of a sideways U there. Make your A and B a little bit bigger. So A is a subset of B because all triangles are a subset of all polygons. Okay, what about here? Look at these fancy numbers or symbols I found on my text. So the set of real numbers and the set of rational numbers. That's what R is. It's the set of real numbers and the set of rational numbers. Are all real numbers rational? No. Square root of 3 is a real number, but it's not rational. Are all real numbers, Q is real numbers, or I'm sorry, quotients, rational numbers? Are all rational numbers real numbers? Yes. All rational numbers are on the number line. So Q is a subset of R, or B is a subset of C in this case, because rational numbers are a subset of the real numbers. All right, and what about vowels and letters in the alphabet? Which one fits inside the other? Well, all vowels are letters of the alphabet, so we would say that set A here is a subset of set B. A is a subset of B because vowels are a subset of all the letters in the alphabet. So there's an example of how to use the subset symbol. Okay, now how about using a Venn diagram to illustrate the relationship between the sets? And then we're going to find A union B. Or I'm sorry, A intersecting with B. I'm sorry, I used the wrong thing. But that upside down U is an intersect symbol. So, all right, we're going to use a Venn diagram to demonstrate these. So let's see if there's any overlap in our Venn diagram. I'm assuming you're a little bit familiar with Venn diagrams. But I see the number 12 in both of our sets. So there is an overlap. So there's A, and there's B, and in their overlap, 12. Set A has got 3, 6, and 9, and set B has got 5, 15, and 20. So what is the intersection then of set A and set B? It's a new set, and that set is 12. 12 is the only number that's between them. What about all parallelograms and all trapezoids? Are there any parallelograms that are trapezoids? Well, parallelograms have two pairs of parallel lines, whereas trapezoids have exactly one pair of parallel lines. So you can't be a parallelogram and be a trapezoid, and also you can't be a trapezoid and be a parallelogram. So the Venn diagram on this is kind of weird looking because there's no overlap at all. So we've got our parallelograms. And we got our trapezoids, but there's no overlap at all because there is never a parallelogram that is a trapezoid. There is never a trapezoid that is a parallelogram. Either. So the intersection of A and B is empty set. There are no such thing as a parallelogram that is a trapezoid or vice versa. So we'd say empty set. You don't need the set notation symbols when you say empty set because there's nothing in your set. Your set is empty. Use the Venn diagram to illustrate the relationship between the sets. Then we're going to indicate the union of the sets. So what's the union of the set 10, 20, 30 and the set of 10 or 20, 30, 40? Well, again, the same thing I'm going to do on this one is the same thing I did before. I'm going to look for any overlap between them. Well, 20 is in both sets and 30 is in both sets. So when I draw my Venn diagram, I am going to have an overlap, and that overlap is going to include 20 and 30. The first set's got 10 all by itself, and the second set's got 40 all by itself. So the union of these two sets is writing them both together, 10, 20, 30, and 40. You're not going to write 20 and 30 twice just because they occur in both sets. We only need to write them once. Now, J, we've got some sequences here that go on to infinity. So the first set is 2, 4, 6, and 8, and so on, so going up by 2s. And the second set is 4, 8, 12, so it's going up by 4s. So is there any overlap? Yeah, I mean, all the multiples of 4 are in both sets. 4, 8, 12 is going to be in both sets, 16 is going to be in both sets, 20 is going to be in both sets. So really, like I just said, this 12 is actually in both sets too. So this Venn diagram is kind of crazy looking too, in that this Venn diagram Actually, the set 4, 8, and 12 is totally inside the 2, 4, 6, 8. So you can see I kind of adjusted it. The union is just the first set, 2, 4, 6, 8, and so on. So again, I took this second set. It fits totally inside the first. I think you'll agree with me that it does. And then, what I'm writing in here is indicating what's not in this circle. So this circle, the smaller one, includes 4, 8, and 12. This includes all the multiples of 2 that aren't multiples of 4. Maybe that's the best way I can say it. All the multiples of 2 that aren't multiples of 4, like 2, 6, 10, 14. 16 would be in this small one. Okay. And there's the union, 2, 4, 6, 8. Some confusing stuff today. I could definitely see you watching this more than once and having to refer back to these notes when you see these symbols. And if you take good notes, that's what they're for. All right. We'll come in tomorrow and get some more practice. I'll see you then.